Hello, my name is Jay Riendeau, Product Manager here at Makino. Today we're going to be talking about the DA500 and machine options to improve your productivity. Today we're broadcasting from our headquarters for the Americas here in Mason, Ohio. So today we're going to go through this Experience Center event, which we call an EC. And then at the end we're going to have a Q&A period. And in that Q&A period you can submit questions. We'll be able to answer those as time allots. So without any further delay, let's get going on into this and take a look at the DA500 and what it has to offer for you. Just a quick product overview on the DA500, a little refresher. Some features of the DA500, this is a high-speed 5-axis milling machine, vertical machining center. The idea behind this machine is high productivity. Many things that were engineered for this machine were done so that we would have reduced non-cut time and try and get the maximum productivity out of the machine itself. It's designed with high reliability, agile for that production efficiency, rigid structure, thermal control, and then obviously with this, right from the inception when the machine was designed, we had automation as a focus for this machine. So with it comes some space-saving pallet magazine options, other tool magazine options, and then also some other features that were designed into the machine for efficient coolant and chip evacuation. From a market perspective, DA500 is a very flexible machine. It has the ability to span across many different product lines and markets and applications that are out there. We have integrated milling and turning operations, because this machine does have turning capability as an option. We could be producing parts for power generation, semiconductor industry, medical instruments, aerospace, even die mold, and then also precision manifolds. So it has quite a bit of capability available. First thing we'll talk about today is the active thermal management. So for this machine, as a standard built into it, we have active thermal management. We have oil circulating throughout the entire machine, meaning the ball screws, the spindle, and also the driven axes for our A and C axis. So we have temperature control oil circulating through all these entities continuously. It's constantly circulating. So as we build up heat or generate heat in these different areas of the machine, that heat is then carried off back to this temperature controller. This temperature controller goes further. It takes that temperature back down to within 2 degrees C of the bed casting of the machine to help control any kind of thermal expansion on the machine. With this type of active thermal control, critical machine systems, provide sustained machine thermal stability for more consistent part process. You don't have those large variations in your parts from start to finish, even over long operating periods of time. So what this active thermal management does for us is it provides sustained machine thermal stability for more consistent part process. No longer are we required to do extended machine warm-ups to attain that thermal stability before putting the machine into full production. Some automation options for this machine. As a standard on this machine, it is equipped with a robot shutter. And what we mean by that is at the far end of the machine, as you see here on the right-hand side, we have a couple of cover panels that are on there. Those cover panels close in the area where this shutter mechanism is located. So on any of the machines that we have equipped here in our market, that shutter is present. So this machine is automation ready. We have the ability to easily retrofit pallet magazines or robot automation. And then also as a feature of this, the way the splash guard is designed, if you do have automation out in front of the machine, we have the ability for coolant and chips to go right back down into the machine itself. And you can see there's an oil pan or a catch area in front of the machine. So the first automation option we're going to talk about is the DA500 and the pallet magazine that was designed specifically for this machine. So you can see here we have the DA500 as a standard configuration on the left-hand side. And then once you add the pallet magazine here, we have a little bit of an extension towards the front of the machine on the right-hand side. With this pallet magazine, you have the ability to further increase the productivity of the machine itself. We have the ability to put different workpiece sizes on here, and it can also be easily retrofitted onto an existing machine. So if you purchase a machine today and buy it with the pallet magazine, or you purchase the machine in the future, we still have that ability to put a pallet magazine on the machine itself. Here's the operation of the pallet magazine. You can see it lifting a pallet, retracting it back out of the work zone, the shutter closes, and then the pallet magazine indexes around and selects the next pallet that will go inside of there. With this pallet magazine, we have the efficient use of floor space. We also have the ability to do mixed milling and turning operations. The pallet magazine operation is fully integrated into the machine control, which is on the Pro 6 itself. And then you have the choice of either a 400 or a 500 millimeter pallet option for this. Here are the different pallet magazine options available. So we have 4 different specific configurations. First configuration on the left-hand side here, if you happen to be doing some smaller work, smaller diameter, and you don't require as much space inside the machine, you have the ability to load more work inside that pallet magazine. So in this case here, maximum diameter is 550 millimeters, and you can get up to 8 pallets for that. If you're doing a little bit larger work, more medium-sized parts, we have the next selection, which is a 6 pallet version, and we can go up to the maximum of 680 millimeters. And maybe if you're a job shop and you're doing mixed work, maybe large parts, maybe a combination of small and large, mixed things like that, we have the ability to configure the pallet magazine with both large and small pallets on there. So 2 800 millimeter pallets, and then also 3 550 millimeter pallets. And the last selection, if you intend to do just large work throughout your entire production period, this is a 4 pallet configuration. And with this 4 pallet configuration, it gives you the maximum work piece size, which is 800 millimeters. Currently, the way it's set up is for the 8 pallet and the 5 pallet, those can be ordered from the factory with a machine, or we can order it as a retrofit option kit. So it can be ordered, but there will be a period of time for delivery. For the 6 pallet and for the 4 pallet version, we will stock those. So please contact your local sales rep, and you can see what our stocking availability is on those. Some tool magazines options that we offer. First one is our base option, which is 60 tools. This is standard on the machine. So maybe you start with the machine as a base configuration and no pallet magazine, no other options on it, and you start production. Then you realize you need to add on a pallet magazine, and for that pallet magazine with all the additional work, you also require more tools. We have the ability to take the 60 tool ring, then expand it out to 118 tools, and this can be done in the field. The last option that we have available for high tool capacity is a 311 tool magazine. This magazine was just introduced earlier this year. So not only do we have a 60 and a 118, we also have the high capacity 311 tool magazine. This is something if you have many different jobs that you run, or you have the ability to integrate this with some automation pallet magazines, integrating it into a vehicle system of some sort, this would probably be your magazine option. So instead of having rings on the side of the machine, we have a rack system inside of there, which is servo and ball screw driven, that goes over and selects tools, and it will deliver it to the machine. For this particular option, this 311 tool magazine can only be ordered as a factory order option with the machine. This is not retrofittable. So please check with your local dealer, your local representative for Makino, and see if we have stock on these. So with this 311 tool magazine, we also include a convenient way to load and unload tools in this. Remember, you're in high production, you don't want to stop the machine. Being mindful of that, we have a tool load drawer system on the side of this tool magazine where the operator can walk over, he can rotate the cam actuated lever on there, it will go over and extract the tool out of the tool pot and deliver it to the operator, which you see here on the right hand side. From that point, he can exchange the tool, return that tool back into the tool magazine, and then also for convenience, we have an HMI located directly above where that tool load drawer is. So he can monitor the tools, check on life, check on status of different tools, whatever is required. Other options for this machine, being that we have a 5-axis milling machine, having a turning option is also extremely useful, and that's one thing that has been integrated into this machine. So we do have a turning option available for this machine, and that must be configured from the factory. It cannot be retrofitted. So with this, we have full 5-axis milling capability, and with that also, we have turning available. So all depending on the type of part that you require, all depending on what you're doing as far as your milling operations, maybe a combination of milling and turning, you now have that flexibility to take your machine even further with this capability. Along with this, because there is potential to make other types of chips, in some turning operations, it's very difficult to prevent any stringy chips from happening. So with this, we also equip the machine as a standard with an internal hinge belt conveyor. So if anything gets caught inside the machine, it will exit the machine. It also comes standard with a dual layer lift-up chip conveyor. This is the chip conveyor at the rear of the machine. So as you pass those stringy chips through the machine, we just want to make sure that nothing's going to get caught in there. So with that, we also equip the machine as a standard with a dual layer lift-up chip conveyor. Since you have milling and turning operations, we also provided other option content available for this machine where we have laser tool length measuring, and then we also have a small touch setter probe, maybe a little bit difficult to see here, but there is a touch setter probe available, so you can monitor both your turning tools and your milling tools. Another feature of this is the balance check function. Being that you could have milling and turning operations, once you've gone through maybe your milling operations, that part that you started with may not be a part that's symmetrical, so it could be out of balance. When you get to the point in time where it's time to do the turning functions, we want to make sure that we're machining in a very controlled manner. We want to make sure we can go through, check for the balance on this, and then we want to go through and balance this as best possible to get to the necessary RPM that you require. This helps to avoid any kind of issue with deterioration of the machine's surface quality, accuracy, and also it saves the life of the machine. So what you'll go through is you can go in here, run the balance check function. The display on the screen will show you where the imbalance is. It'll show you the location where you need to add weights. And then you can add or subtract weight from that to get the proper balance for the process that you're running. Next thing we'll talk about is process monitoring. We want to ensure that while the machine is in operation, we're monitoring our tools. We want to make sure that you don't inadvertently run into a situation where you could have a broken tool and then potentially scrap a part. So as a standard on this machine for broken tool sensing, we have what's called a Vision Broken Tool Sensing System, or we call it Vision BTS. What's happening here is we are taking an image of that tool and the light flashing in the background, and we're taking that image and comparing it to a previous image of that tool as it was originally registered in the machine. So it's a non-contact validation of the tool. So for some reason, if you're running a drill and then you have a tap running behind it, if you happen to break that drill, this will prevent that tap from going back in behind it and potentially breaking off inside of your part. The other functionality that's also included that's relatively new is tool monitoring. So with this system here, you run many production tools. They're continuously running in the machine. What we can do with this system is, because we are taking an image of this, we can ensure that we don't accidentally have an error where we loaded a tool that is not correct for that particular tool number. In this case here, we have tool 1235, and you can see it's been registered one time, it's gone through, it's been registered a second time where it's passed through that Vision BTS system. Let's say that tool life's out or something happens to it, the operator goes through, he exchanges that tool, and now that new tool comes in. When we're expecting tool 1235, which should look like this long gun drill, in this case here, the wrong tool is loaded. So what this system will do is, comparing previous data, it will prevent you from accidentally running the incorrect tool that's in there, thereby preventing any kind of damage to your part, process, or your machine. Other control and software functionality that's built into the machine, we have a system that's called Inertia Active Control. We want to operate the machine at its maximum capability. And that maximum capability may be at a limit, all depending on what kind of mass there is on the table. Obviously, the lighter the mass, the faster we can go. The heavier the mass, the slower we're going to have to go to be able to move this part around in a controlled fashion. In this case here, we have an example of each one going on. First one on the left-hand side here, we have a 60 kg part. On the right-hand side, we have a maximum weight part for this particular machine, which is 250 kg. The program that's going to run for both of these is identical between the two. You can see the part on the left-hand side is taking advantage of that inertia active control. It's looking at the mass that's on that table, and it's allowing the machine to operate at a higher level or a higher rate of speed, which helps to shorten your part production process, higher efficiency for the machine. On the right-hand side, we have that heavier mass part. Now we're trying to operate or maneuver that machine in a more controlled fashion. So one, we maintain the accuracy of the machine for our part production, and also it extends the life of the machine. Other functions that are on the machine, what's called GI drilling is next. So instead of having a square wave motion where you're going through, drilling a hole, retracting all the way out to a defined point, and then going back in after you've made a move in a different direction, what we have here is the ability to arc or move smoothly by interpolating that motion. So that smooth arcing motion allows us to move quicker through a whole drilling cycle. We also have milling functionality that does the same thing, what we call GI milling. And in GI milling, you have the ability, as you can see in this diagram here, with the GI milling off, we're running around square corners. With the GI milling on, we're more of a rounded corner. So you can set how much tolerance you want as you're passing around corners. This helps to improve the efficiency of the machine. In this case here, this is the exact same motion for both. One with it off, one with it on, and it's about a 35% cycle reduction. Next thing is GI breaker. So inevitably you will run into things in your process where you can no longer break that chip, and you could potentially have stringy chips. These stringy chips get carried throughout the machine. They can interrupt your process. They can cause other problems. With GI breaker, what we're doing is in a controlled fashion, we're changing the feed rate just ever so slightly so that we're actually facilitating that chip to break off as it's being drilled out of the pocket. On the left-hand side here, you can see where GI breaker is active. And we're making chips. You can see they're relatively long, but we're still making chips. Nothing's getting caught. On the right-hand side, we have that chip wrapped around there. GI breaker also works for our turning functionality in this particular machine as well. Next, we have collision safeguard. So being that we're running this machine in a high production environment, we need to protect our parts. We need to protect our investment. So we have a collision safeguard system on here. And what's happening is we have two things going on. Two states here, the top and the bottom. Top here being the real world. This is where you can see our milling cutter processing and cutting across the part itself. And then potentially right over here on the far side, we have our fixture. On the bottom, we have the computing world, or our CSG world. What's happening here is this CSG world, it's computing and looking at all the data. It's looking at everything that you've input into the machine to understand if there could be a point in time where that tool could potentially hit your fixture or the workpiece. In this case here, what it'll do is, because it is running ahead and it's monitoring that, it has the ability to look ahead, understand where a good, safe, predetermined stopping point is, and it will stop the machine before it ever impacts that part. This works in real time. It takes into account real machine conditions, and we have a couple of levels that go along with this. The standard functionality on here protects the machine itself. It has model data for the spindle, table, other features of the machine that could potentially impact each other. We also have another level of it, which is called level 2. With this, it's functionality with user data. So you can take your fixture data, your part data, all of your tooling data, put all that data inside the machine. Then it will take it to the next level and actively monitor everything according to the data that you put in there. So a much finer, better refined process to help protect the machine. This also works in manual mode. So if you're moving the machine around, let's say jogging it, or moving in a rapid using the hand wheel or the MPG. It will also protect the machine while it's in any one of those manual modes. Next, we'll talk about coolant and chip evacuation. So you can have a great robust process, you can have an excellent machine, but if you can't manage those chips, you can't deal with that in a controlled fashion where you can run for long periods of time without having to stop that machine, you'll start to reduce your productivity. Next thing you know, you have operator intervention, you have people going in there that have to clean this out. So it plays a key role in the uptime percentage of the machine. And remember, idle machines don't make money. So in this case here, we have a smartly engineered machine. We try and mitigate that chip buildup and also help to reduce that coolant contamination. So something to think about, how often are you having to stop your machine to clean out chips? And also, is chip buildup interrupting your process? If these things are happening, you're starting to lose efficiency for the machine. On this machine, you'll notice that the interior walls are vertical, so it helps to shed chips and return that coolant back to the coolant system very quickly. Good, efficient chip evacuation. And then for the areas of the machine, that we do have flat areas where you cannot get that vertical wall in place, we do have some nozzles that are strategically placed. That way there we can flush the coolant through there and we can evacuate those chips. Other features of this coolant system, we're thinking about the operation of the machine in the long term. We want to reduce maintenance time, and then what we do here is we have a high volume secondary filtration system that is standard on this coolant system. So this hydrocyclone filter here is constantly circulating coolant through it, helping to extract that particulate that's in suspension. In order to keep that particulate in suspension, standard functionality on this machine, we have coolant agitating nozzles inside the tank. Those agitating nozzles help to keep that coolant moving, so a healthy coolant environment. It also helps to prevent any settling of particulate in there. So as this is agitating, we're also going through and we're extracting particulate out of that coolant. As I was mentioning earlier, also standard on the machine, because it can see many different environments of chip cutting and part processing, this machine comes standard with a dual layer lift up chip conveyor. So hinge belt chip conveyor over the top of a scraper drum conveyor. And as the coolant gets processed through there, all the large chips get carried off by the hinge belt conveyor. And then small particulate and coolant passes through the hinge belt down into the scraper section. And then in the scraper section, we carry the small fines and particulate away by scraping them out of there. And then 100% of the coolant flow passing through the machine goes through the drum filter and it's filtered out before it enters the rest of the coolant system. Other features, if you happen to purchase the pallet magazine option, we also include a coolant flushing system on that pallet magazine. Just one more thing for that long-term operating that we don't want to have to stop that machine to go in and periodically clean it out. We want it to run continuously. In this case here, we have coolant flushing inside of there as that magazine rotates around and indexes to select the next pallet. And it directs all the coolant chips back out of the machine, back out of the pallet magazine, back down into the machine in the center here, which eventually goes into the end of the machine itself. So trouble-free, unattended operation of the machine. One thing even further, if you think about this, so now we have a pallet magazine operating for extended periods of time, most likely in some sort of an unmanned type application. The last thing you want to do is have some sort of a misload of the pallet. Included in the pallet magazine also are some flushing nozzles. These flushing nozzles are on either side of the lifting fork that lifts the pallet up when it does the exchange. So what we'll do here is, as we're lifting up that pallet, we're going to flush off the bottom side of the pallet. And we're going to prevent anything like you see here from happening. We have the potential with all these chips right here. These chips could get caught inside the seating surfaces between the clamping cones of the pallet. And if you have some sort of a misseat option or you have chips caught in there, you can affect your part process or it will stop the machine. We want to prevent that from happening. So further extend the operating capacity of the machine and eliminate some of those nuisance faults that potentially could come with it. Here's the pallet flushing system in operation. So it's spraying the underside of the pallet with those nozzles. and it's doing so to help clean all that debris away. Once it cleans that debris away for a short period of time, it will go through, unclamp that pallet. We can lift that pallet up, and then we can do the exchange. And this is standard when you buy the pallet magazine option. So that concludes our Experience Center event for today. If you have any further questions, we have some contact information here, or you can contact your local Makino representative. So now we're going to move on. We'll get to our Q&A period, and we'll answer those questions that have come in during the event. Thank you. Well, everybody, thank you very much for attending our Experience Center event today. For the people that have attended, you will get an email with a link in it. So you can go back and review this once again if there's anything that you happen to miss. We do have a couple questions that popped up in the queue. One of them from a user here. They're asking about, they're running mixed metals on their machine, stainless, other hard alloys, and they're asking about if high pressure through the tool coolant is available. We do have options available for this on the machine itself. The machine as equipped, meaning as it is built, it is prepared for high pressure up to 1000 PSI or 70 bar. Another question in the queue here. How similar is this machine to the DA300? The DA500 is actually kind of like the big brother to the DA300. If you pulled all the sheet metal off the machine, a lot of the design characteristics are very much the same between the two. Obviously, with the DA500, things are scaled up quite a bit. So servo systems, things of that nature, are sized appropriately based upon the structure of the machine, the mass that we're moving around. And I think that's about it for the questions today. Once again, thank you very much for your time, and you will receive that email with the links in it, and you can review that again. Thank you.